Okay, here's the solution to homework number 5 or 6. I can't recall the number. So we had two questions, and I'm going to cover it in two separate videos. Okay, I will start from the ball and ground problem, like a ball and ground setup without any motion study associated with that. First I have to check the mates in order to make sure that we have all the mates suppressed to give them degree of freedom. So first of all, the distance before we suppressing, we can give it the distance that the problem requested is 120 inch. That is going to put the ball at the proper distance from the ground. When the initial distance is okay, we are going to suppress this mate. So essentially, the ball can freely move in the vertical space. We keep this mate to keep the ball at the center of the ground, and we have to suppress this mate as well to allow the ball freely moving. Okay, the problem asks for ball initial velocity at 180 inch per second with 40-degree angle with respect to the ground level, and we don't have any geometry here to define that direction. So in order to give that the proper dimension, we are going to go back to the model space, and we are going to create a sketch here on front plane. Front plane is very small, but essentially that's a proper sketch area. And all we have to do, we have to just draw a line here with a 40-degree angle with respect to ground. And that would be the exhibit sketch. You'll see that this line is going to properly, the line should not be necessarily at the ball, it could be at any place, because all the line is going to provide is the direction of the initial velocity. Going back to motion study, and now we have additional sketch that we had that. So what we are going to do is going to right click, select the ball and right click on it. It would be adding for initial velocity, and here in direction we are going to select this sketch, which would be correctly here, and then it would be 180. So that would be the direction of that. Okay, other than that, we are going to have a coefficient of restitution. Since this is a ball here, what we are going to do, okay, we have to define a contact between two solid bodies, between the ball and the ground, and when these two selection complete, we're going to go down. Material, we don't want it, no friction. All we need is coefficient of restitution with a given value of 0.65. The other simulation setup that provided by the problem is going to be, okay, first of all is 3.5 seconds. We will drag it here, zoom in, and also we need to define gravity. So it's here. So gravity, initial velocity with that angle, and I think that's all we need. Then we're going to go to simulation setup. Number of the frame per second is 500, and we are going to use 3.5, which already did. Precise accuracy at 0.1, and hit OK. We should have everything for setup. It's on the motion analysis, so we are going to simulate that. You see it's going to provide that initial velocity. Okay, that was all we needed here. If we are going to play back, we'll see that that's pretty much accurate. So what problem ask is to submit the following. Number one, ball vertical position with respect to time. So we are going to go to plot, and this is a displacement. We are going to be center of mass position for the position of with respect to time. Actually, it was ball vertical position, so it's not center of mass. It would be linear displacement. And it wanted in y direction because that's a vertical, and component is the ball. And essentially, that would be what it was requested. I guess I can actually save this result somewhere. I believe it's going to a spreadsheet. Let me see if there's any other option. No, was hoping that I can take it like get this picture or anything like that, which actually I can make in a screenshot, I believe. Before doing that, I can rename this by going to say ball vertical position. It's going to change the title as well as renaming this one. Now I can go to the screenshot. I think it's a window mode, which would be this. And I have this. I'm going to get this one. I'm going to post it to the canvas. Okay, I'm going to come here, I believe, class 8. So that would be Q1, plot 1. Okay, and then the other thing that it was is ball vertical velocity, which would be easy displacement, linear velocity in y component of this ball, which is what we wanted. Again, I'm going to rename it ball vertical velocity, and then I'm going to save it again to the same folder, which would be class 8 solutions, and that's plot 2. Okay, and that's all we needed. Thank you.